All right, so today's session, I'll be sharing about building products and equipment in manufacturing. So this is this is somewhere in between both manufacturing and also construction. So this is how manufacturing customer or manufacturing company get more value from constructions, which is booming now. Okay, so before we start, of course, the most important slide of the day is my introduction, which is my name is Syed Zulkarnain, so you can just call me Syed. So I am the solution consultant manager for Autodesk Design Manufacturing, Architecture and Construction, and also Media Entertainment. So basically the technical manager for all these three industry pillars. Okay, so a quick intro about my company. So we are called TechD in Malaysia. So globally, we are known as TDC Next, and in APAC, we are known as Tech Data. So there are multiple names here, but just think of us as TechD in Malaysia. It'll be okay. So we are a company with 23,000 plus co-workers. Okay. And then we so-called number 64 on Fortune 500 last year's, and also a Fortune World Most Admired Company for a few years already. Okay, so our so-called global entity, so global company started back in 1974 and up until now. Okay, along the way, there are some mergers, acquisition, and so on. Okay, we are also located all across the globe, from North America, Europe, APAC, okay, and so on. All right. So as you can see, we have there's a DATEC at the screen there. So basically, DATEC is the divisions or departments that only handles Autodesk products. So in our company, there are multiple line cards. Okay, so we are the global distributor for all Autodesk products. Okay, so Autodesk ecosystem within TechD. So within TechD, so our local entity here. So we are not just dealing with software. Autodesk software, we are also a distributor for a lot of hardwares and other enterprise and business related softwares. Okay. Okay, so straight away to introduction. So all the solutions or applications that I use today to show all these benefits and so on is all belongs to Autodesk. So Autodesk started in 1982 with the most famous product, which is AutoCAD. I mean, that's the pioneer products. Okay, so Autodesk have three industry pillars, like I mentioned earlier: architecture, engineering, and construction, manufacturing, and also media and entertainment. Okay, just a quick run through. This is on the left-hand side. This is when was back on the days where we use manual drawings, and nowadays everyone is going towards PCs and also 3D modeling and so on. Okay, all right then. So agenda of the day. So I simplified everything to four big titles. Okay. We'll start with an overview of BIM manufacturing first, and then some industry trends and drivers, and then a quick break before we go to solutions and tools. And the last one is the new topic, which is design and make static, which basically to connect. So how do manufacturing industry, so those all the building products, equipments, building products manufacturers gets more value from industrialized constructions. Okay, so again, in case there's someone just joined, so you can please scan this QR code, or you can see there's a link at the chat box. This is to entitle you for a lucky draw later, which we will courier over to your locations. So please make sure to add valid details. Okay, all right. So the first one, so overview of BIM manufacturing industry. All right, so nowadays everybody keep talking about BIM, what is BIM, and so on. So what is BIM? Okay, so what manufacturing customer may think about BIM? Okay, so if I rephrase my question from earlier, what is BIM? I believe everybody probably have somehow Google or read somewhere about what is BIM. Okay, what manufacturing customer may think about BIM? Okay, so a lot of factories or manufacturing customers that we met, they think they do not need to know about BIM. They do not require BIM. BIM is somehow a 3D model for architect or for constructions. Okay, it just costs more money, or maybe something mysterious that manufacturers do not need. Okay, but what is BIM and when it is required? Okay, so this is all concerns all company involved in construction project. Okay, this is process, not a tool. Okay, helps to identify issues. Okay, can reduce cost and on-site changes. So in every construction, so in every building nowadays, there is always manufactured components, right? So let's see what is the manufacturing concept inside building. Okay, building information modeling. Okay, so to all the stakeholders, you can see all related to BIM, all the project owners, architects, civil engineer, the structural engineer, MEP system engineer. So this one, if you are in probably HVAC, you're doing ductings, okay, you're probably in this area of firefighting, and then builders and manufacturers will also add it to the projects. Okay, so the convergence between BIM and manufacturing. So where is it? Okay, so building design and building products. Okay, so this is where example in this example is the you can use elevator or escalator as so-called a building product or building equipment, right? So for this kind of product to perform correctly, right? So they need the correct building model or building design or building measurement and so on, right? So basically they need to be collaborated. So they need to work together. In case there are some changes on the building design, the building product will also be able to address and amend accordingly. Okay, so what's the manufacturing components in BIM? All right, so there are five, okay, simplified into five manufacturing components in BIM. So building products and equipment, as you see on the photo there, probably the cooling system, HVACs, elevator, okay, and then custom fabrication, things like all the nice stairs you saw, probably the exterior of the buildings, okay, and then building equipments and layout, all the facade and so on, okay, modular constructions where some things that I mean, you already you design a building or a room or a space with a modular construction where you can always add more or change accordingly in the futures. Or and then AEC engineering, so engineering services that are related to architecture, engineering, and constructions. Things like probably pipings, okay, steel structures, and maybe things like the simulation of how the gas or the aircon move within a building. So all this is firstly as manufacturing components in BIM. Okay, in case you have question, you can straight away type it at the Q&A or chat box. I'm not sure which one is you're able to access, so you can always type in the question there. Okay, again, a bit dive in deeper into what is manufactured component of a building. We can see in this example, we have a steel structures. Building will have steel structures, the factory and everything, curtain walls, prefab, okay, prefab components, okay, factory assembly layout, in case there's an assembly, prefab, again, custom casework, doors, windows, lighting, interiors, so all that. Okay, all the custom architecture component, roof, staircase. So all these need to be manufactured, right? They need to be so-called, some of them probably need to be machined to get into shapes. Okay, so you go into here, things like under prefab, concrete, steel, piping, ducting, wiring, custom architecture component, things like roof, staircase, revolving doors. So all that is considered a manufacturing component. Okay, curtain walls, custom casework, furniture, doors, lightings, and so on. Can my manufacturing model be added in? Okay, I saw some question. Can my manufacturing model be added into the BIM software library? The answer is yes. Okay, we'll see. We'll learn more about that later. Okay, I'll show about that later as well. Okay, then the next topic is more on industry trends and drivers. So industrialized construction. This is something that people has been talking about. Okay, the future is industrialized. So what does it mean? Now, productization. Define building products to scale manufacturing process. Okay, optimize. Okay, so in the future, so we'll combat our housing and infrastructure crisis with manufactured buildings. Okay, we'll drive up sustainability of building and use of all the products component. Okay, in order to meet demand in a safe, sustainable way, we need to manufacture building and not approach each building as a prototype. Okay, this will allow the industry to take advantage of the repetitive and mass customization to allow any process to be scaled up or scaled down. Okay. Then design with guardrails. Okay, to use building product at building design, data-driven design using accurate data. Okay, so you know how people get going back and forth about this amendment on this design. Okay, if all this can be centralized, it can be collaborated or addressed earlier. Okay, the future is here where generative AI-based design can also help you. So all that customizations or cataloging, okay, information of a building or a house is already there out in the market. Prefab versus products. Prefab is basically assembling a component off-site, okay, and then transport them to the construction site just to install. Okay, prefab focus on efficient assembly and waste reductions, while product is turning all the internal skills, all the informations into a products. Okay, so for broader use and promoting sustainability and better building practice. Okay, so far any questions? If I don't see any questions, right. Okay, so there's some forecasts that over the next 15 years, so around 45% of AC or construction value chain will shift away from traditional processes and move towards prefab or whatever that I mentioned earlier on. Okay, so increasing pressures, okay, so government requirement incentive for global proof points, okay, so from architects to general contractors. Okay, 1 moment. All right, so modular constructions. So this, as you've seen, things like has been very common for a trend. You see probably the most common one or well-known one during COVID, where China built all the hospitals. Okay, offsite custom fabrications, product layout. Okay, AC engineering, where we build all this. Okay, so if you see all the nice bridges, okay, that is probably been manufactured. Okay, you see all the steel or the frames, all that is manufactured, designed and manufactured. Okay, building equipments, HVAC equipments, okay, industrial machinery. This all is inside a buildings. A product layout like a factory or production line, okay, to serve the products or equipments. Okay, an example. Okay, So next we look into digital constructions and project development. So when we talk about project, collaboration is key. Okay, how you collaborate with your all your stakeholder or your internal team members is very crucial. Okay, so in case that you are still collaborating manually or maybe I was still using WhatsApp, emails for project collaborations, you probably need to look into a better platform where every data, every communication is centralized for data trackings and project developments to be more efficient. Here is examples of how common data environments will help, and what happens if you don't have a proper collaborations.
Pete, where are the ducks we ordered?
Yeah, I think they're leaving now.
About time.
I said ducks, not ducks. Ducks.
Improve communication and increase collaboration with Autodesk Construction Cloud.
Okay, so that's an example. Okay, of course we put it in a funny way, but it can happen, right? Something that we need to move forward with all this digital transformation. Something that Malaysia is going forward. Looking forward to. Okay, and then this is an example of a virtual twin. Okay, so in this case, it's an Air Force base. So you can see on the right is a walkthrough. Okay, this is all pre-built. Okay, on the left-hand side is the process, the timeline, how long it takes to build. Okay, based on all the project data input. Okay, we can forecast how long will it takes to build a project. On the right is for us to do a walkthrough to see. It's like we're there. You can always use things like VR, or if you don't have VR, we also have platform which will able to help on these visualizations. Okay, so this is all to address all the, not to say mistakes, all the probably clashes. Okay, so that we can address all the amendments early before the constructions production starts. Okay, connected tools. Okay, so it's good to have a connected tool where all your design, collaborations, in this case, all these clash detection, scheduling, all under the same platforms, where things like, example, we are moving from, let's use example of we scan. Okay, 3D scanner, we scan an existing structure or existing buildings. Okay, and then we can use that point cloud data to add to our project. So it becomes, so we don't have to work with maybe legacy drawings or old drawings, right? So we can use point cloud data. So by using point cloud data, we can also do clash detections. Okay, so we can detect maybe there's a beam inside, there's a beam on site that is not on the old drawings. Okay, we can do clash detection between our 3D models or our design with the existing structure, where we use point cloud data, where we scan, right? So we can run tests between our digital data and the point cloud data. Okay, you can see my model now is clashing with the beam, all right? So what we can do is we can address our design data, right? We cannot move the beam, but we can move our so-called project or our equipment. So from here, we will know that we need to move it. So all this happens before construction or production starts, before we putting in or bring in all the equipments. Okay, this is to help with to make the project planning more optimized and more efficient. Here is an examples of a plant. So in case you are in process plant, or oil and gas, okay, probably you're doing RO, okay. So we can use a platform to, in this case, it's Navisworks to do all this checking, okay? Because sometimes certain company or certain projects, not everyone need a CAD applications to review. But instead, you can use something like, in this case, it's Navisworks to review the file, to do markups, to do clash detections, and then whatever the changes that need to be done, they send it to the designer, to the drafter, or to the engineers to make the changes. Okay, all the clashes can be documented. Okay, between what component, what file, and what files. Example. So in this case, we see that it's a very big plant. Okay, probably we are going to, in this project, we so-called is expanding. So adding a new plant. So we need to figure out how to connect one plant to another. Okay. And in this case, example that you have different contractors that handling all the equipments and different contractors that handling the steel structures, the frames. This is where collaborations and coordinations need to be done correctly. Okay, by doing this digitally, you save a lot of time and cost rather than have to face this on-site changes. Okay, so this is an example of how project planning or project timeline is done. Okay, so you can all add all the information from Microsoft Project or Primavera or whatever that you use. Okay, so you can run the timeline. You can see that's okay. According to the timeline, you can see what level or what equipment has been added to the position there. Okay, so this is for project planning. So you can forecast how long does it need, how long does it take, what is the expected issues that will comes in. Okay, all right. So next one. All right, so for this, I need help from your side to this one I need mobile phone. So you can use your mobile phone to screen capture, to scan this QR code, and please help to type at the chat box what did you see. Okay. Okay, can you try to open up your phone, try to scan the QR and see and tell me? And tell us on your screen, on your phones. I'll leave it up for you. See if anyone willing to share us. Tell us what okay, try. You can use your phone to scan the QR code and tell me if it works. Tell me what you're looking at. So maybe the audio just now was a bit loud. Tone it down a little bit. Think that you can hear me. Okay, anyone want to share what are you looking at on the screen? Progress and final products. Or maybe, okay. Maybe we should say visualizations. Maybe. Okay, so let me just fast forward then. You're probably looking at something like this. Okay, so this is a visualizations of a factory. Okay, in this example, it's a factory. Okay, so this is for you to differentiate yourself, showing different, instead of sending photos or videos, you can do something like this. Okay, use QR codes, okay, to show the design of every department, so every divisions or every scene for collaborations. Okay. Then we look at smart buildings. Okay, thank you for sharing. Fire system, conveyor, warehouse area. All right. So now let's look at smart building. So what is smart building? So,
Open Digital Platform, a district management system that enables efficient management of multiple estates across Singapore. The platform converts and displays sensor, geospatial and building data on an integrated 3D platform. In the country overview, enable map overlays of weather data, sensor data, and transport, aircraft and maritime vessel data. Capture open data from government agencies and display useful data geographically. Receive automated notifications according to preset limits. Sent via system alerts or an instant messaging platform. Estate managers can easily navigate across the various estates highlighted. The Estate Command and Control interface provides estate managers real-time updates on estate operations, such as power and water consumption and electricity loads. In the building overview, visualize geographical positions of systems and assets across various building levels and zones in real time. Enable responsive maintenance with the help of real-time incident reports from the digital twin. Assign tasks to the nearest available staff to carry out maintenance and attend to incidents. The JTC Summit, a 32-story, 450,000 square foot building constructed in 2000. Building floor plans are painstakingly converted from CAD to BIM and meticulously textured in 3D to create a lifelike digital replica of the building. The Open Digital Platform allows for seamless plug-and-play integration with existing building systems. Monitor and manage systems such as district cooling and smart grid, car parks, human flow monitoring, fleet management, and urban logistics.
okay, all right. So let me summarize on that. All right. So we have virtual twin earlier. So now it's connected twin. So this is where all your manufacturing equipments, products comes to life. And you need to make your so-called equipments more valuable by adding in all these sensors. Okay, so to add more values to your services so that you can track what's happening, what's wrong, where is the problem. Okay. So this is a way to be more, more effective in a way. All right. All right. And then sustainability in BIM. Okay. So sustainable. So what's, when we talk about sustainable, or what people understand mostly are save raw materials, save the earth, save the tree, right? So 100% of increase in global building floor area by 2020. Okay, this is a forecast. Okay, owing to population growth. So population growth increasing. So we are expecting increase in all the raw material usage. So 40% of solid waste comes from the construction industries. 50% of the global material consumption comes from the building sector. So one way to address this issue is with industrialized construction, where all the manufactured components, so manufactured equipments or modular construction comes into place. Okay, there's a lot of global policies and action to drive all these decarbonizations. Okay, so if you have time, you probably can go through and read, and then you learn, and you can learn how to relate your products or your company to the the trends. Okay. Carbon is the currency of global sustainability. Okay, everyone to go to decarbonization. So there's a lot of solar nowadays. Okay, so just to relate manufacturing to constructions or architecture and construction is this is the BIM sustainability drivers, where sustainable buildings, daylight solar panel, is manufactured. Okay, energy assessment through design and operations, reduce carbon emissions, circular design, repurposing of buildings, or this is where modular designs comes into place, reduce waste and reworks. This is where the prefabs all comes into place. Okay, and optimizations and design automations, all these things that we shared earlier about digital prototyping, digital analysis, and so on. Okay, so where does this carbon in this so-called AEC life cycle comes? Okay, so transportations, construction phase, and most of it are on operation phase. Okay, where a lot of energy and water use, okay, maintenance, replacement, okay, and then once everything's done, it's end of life. So the constructions, okay, demolitions, okay, where did they actually dispose all that waste? Example, in let's say in Shah Alam, so the UMW area, so the factory has been demolished and have been new construction has start. Okay, so where did they do the disposal of the previous factory and previous materials, right? Okay, embodied carbon, operational carbon, and also so-called the whole life cycle carbons. More toward the solutions and the tools for this topic, which is the BIM manufacturing convergence. Okay, so I'm going to use one sample, a curtain wall, as a case study or example. Okay, and then see the BIM interoperability between whatever, in this case, it's Autodesk products, of course, with the leading BIM tools, which is Revit. Okay, and what we can do to expand beyond normal constructions. Okay, so let's say a curtain wall, for example. So how's the flow? Okay, what's the flow? What happened? Okay, what do we need to do? What engineer needs to do to start with thinking out how to design a curtain wall? Okay, so I'm not going to go every product by product to create this. Okay, so I will show some samples. So, but it all most of it start with 2D layout drawings. Okay, in Malaysia, most, I can say, start with 2D layout drawing, either legacy, old drawings, or maybe new drawings. Okay, so how it is done is from that 2D layout drawings, so we create maybe an example of, not example, I call it skeleton. So a skeleton of a curtain wall skin. And then I place all the structured steel on that so-called surface. And then, of course, you know that in this example, we see a lot of all this steel design. They are not all box. Not all is rectangle. Some is square. Some is even triangle. So all these have different sizes and different shapes, okay, in a way. So how do we be more efficient in this way? So we can automate it. Okay, so we can make, let's say, a panel to become annotative. Okay, it follows whatever size or whatever measurement that we want, and it will auto updates. Okay, and then of course the automatic fabrication drawings that created from these 3D models. Okay, on whatever 3D models that we created, of course, also an important factor is the analysis or the design validation, whether the components is strong enough to withhold. In this case, we show some tests on maybe the windows to test the wind and so on. Okay, and then complete assembly with reports and so on. Okay. Okay, so for us, manufacturers of the window, okay, example, I'm the manufacturer of all that window panels, right? So I need the building sizes, the building information. So I need the so-called the building modelers or architect to send me the building as reference, right? Okay, so once I receive the building's model, and I can create my window design template, I can copy it to a building, make sure it adjust accordingly or change accordingly to size, what happens is these connections is not one way. Okay, so in Autodesk ecosystem, so let's say the building design, so there are some changes in the building design. The so-called windows also will also be auto updated following the size of the building, because we are using the building as reference. Okay. Okay, so here is just an example from a normal CAD drawings. Okay, so this is AutoCAD, so pretty old drawings. Okay, so and then from there we move up to our so-called Autodesk manufacturing hero products called Inventor. Okay, we can straight away create all the steel frames, so all the design of the window panels. Okay, the curtain wall system. Okay, so all the libraries is there. All the steel structure libraries with sizes is available. Okay, so Inventor comes with over 1 million numbers of standard components out of the box. Okay, you do not have to pay extra. So this is one of the strength and benefits of using other inventors. Okay, and then with placement, so the rest is just placement, trim according to size or to the skeletons. Okay, so and then I have one done. Okay, so and then from there, so I'll add it to the so-called skeleton, where the so-called surface of the curtain wall system just now. So when I place it, so I place and select from what point to what point. Okay, so it will be moving to the certain point and change accordingly to size. Okay, so you can see that the big one there is of course is bigger. So if I insert one more on the upper side, so it will be automatically changed to a smaller size. Okay, so let's say now I add on the top side. So just choose the points, so bottom left, bottom right, top right, and then it will automatically adjust. So this is the same assembly. Yeah? There's not this panel is the same panel. It's not it's the same assembly file. It's not a different assembly file. It's just it automatically changes in size according to our reference point. Okay, so we don't have to create a lot of copies of a panel, but instead we can use one but make it smarter, so it can automatically adjust accordingly. Okay, this also works with other equipments. So if you're talking about maybe a skid design or maybe oil and gas design, machine design, we can also use the same concept. Okay, but in this case, we're talking about the building convergence. Okay, so I'm using this as reference. Okay, and then the FEA simulation. So in this case, we want to so-called check the strength of the wall, right? So we simulate maybe like 130 km per hour wind load on one unitized system. Okay, we specify the lead loads. So where is the transfer reaction force? Okay, to the brackets. Okay, so that let's say once we run the simulations, we know if maybe we need to strengthen the panel or the wall, or is it over designed, or is it under designed? So we can also check that. Okay. Okay, so it's very simple. So we just assign the dead load of glass. Okay, so specify the wind load and transfer reaction force. Okay, so we can see where is the stress, where is the critical points, whether the critical point is acceptable, whether our yield is acceptable. Okay, do we need to change the plate thickness maybe to something maybe thinner, or maybe we need to improve to make it stronger? So this is where the simulations reports helps. Okay, so this is an example of the frameless glass facade. So stress analysis on the spider brackets, wind load deflection. So all this is done using Autodesk platform. Okay, let me just go next. Okay, so from reusing all the AutoCAD or legacy drawings, okay, to adding in all the structural design using the existing frame libraries. Okay, unitized curtain wall design. Okay, and then smart copy to place for placement. I showed you an example earlier. Okay, automated 2D production drawings. So this is production drawings where all the detail, measurements, and dimension need to be placed. Okay. And of course, visualization, maybe for sales marketing purposes, right? So visualization also very important. The stress analysis that I showed for design validations. Okay. Again, you see one QR code. So I need your help to scan and tell me, what do you see? What do you see on your screen? So what I'm doing here is, so this, I'm just sharing a 3D so-called model, okay? So in case you have time, you can scan. So if not, I'm just going to maybe drag this into screen. Not sure if you are able to see. Let me just do a quick check. So are you able to see the movement? Adrian, you able to see my Autodesk viewer screen?
Yep.
Okay, all right. So this is basically Autodesk viewer. So I'm sending in, I'm sharing the 3D models on the cloud, okay? Without, how to put it? So we are sharing the visuals, okay, without even sending the intellectual property. So there's no 3D model sending over. So it's just visualizations. So what I can do here is, I can do simple movements. Okay, I can do simple, let's say, measurements. We can do measurements. Okay, let's say distance between one point to another. So let's say, from the bottoms to the top of, okay. You can see that we can see the height, okay, or angles, whatever measurement we need to, we can do that. Okay, so if let's say, we want to walk through, okay, we can also do that. Or maybe sections, section views. Let me just skip this here. Maybe create section from here. All right, so boom. Zoom out a little bit. Okay, so this is quite what I say, it's quite a good visualizations. So you can show maybe two sections. Maybe I can show sectioning. It's okay. So maybe I should explode. Let me zoom out a little bit. So for this kind of thing, so let's say we can also share like things like machines and so on. Okay, so we can explode it. So this is on the browser. This is on internet browser. It's not even on a CAD platform. Okay, so we can go in and add some measurements or markups. Let's say we want to add markups. So I can add markups over here, example. Okay, and then maybe add some notes to it. Okay, or let's say, let me just save this. Okay, so we can communicate, collaborate through a scene. Okay, so let's say the issue is done. I can also share the link. Okay, let's say the issue is done. I can only click resolve. So it will be resolved, right? So let me go back to my screen. I saw some. Okay. All right, so that's an example of Autodesk Viewer. This comes free with, I can say, most of the Autodesk products. Okay, that's one of the subscription benefits. Okay, and then now let's look at the interoperability. So we're talking about any CAD here. So basically, okay, Revit is leading products for AC, so architecture and construction software, right? BIM, right? So what we can do is, so we can maintain the associativity between Revit files and also Inventor files. Okay, so this way, whenever there's changes to the whenever there's changes to the so-called building, those who use that building as reference will also get an updated or latest versions of the building. Okay, so this is the cross-industry workflow that's only available between Autodesk tools. Okay, so example, interoperability between Revit and Inventor. So with this data exchange, we can view and filter data, we can consume, make changes to data, we can so-called customize or add notifications, we can understand the version changes, we can visualize the changes. Okay. Okay, so here is the flow, let's say from Revit. So we basically just specify, let's say within the building. So I don't want to send the whole building, but instead I just want to send maybe the porch area, okay, or maybe the room area. So I just define the area of interest that I want to share. So I just share that building information, okay, that so-called area information to the building product manufacturer. And then we can just link the building model in Inventor. And then let's say I'm adding in an awning to the building, right? So I can add my awning, adjust accordingly to size. Okay, updates when there's an update to the building, it will automatically update the one on my model as well. Okay, once the measurement, the fitting, the coordination is done, I can simplify my so-called, in this case, using awning as design. Simplify my awning design because I do not need to send the whole detail to BIM software because they only use the shapes and the size. So the fabrication details I can keep to myself. So I just simplify the design, add connectors of the metadata, and send it back again to the Revit users.
Autodesk Inventor 2023 continues to improve the connections between Revit and Inventor. When working with Revit and AEC data, engineers and designers typically don't need the entire model or the full detail. The new data exchange workflow makes it easy for Revit.
Talk myself. So from Revit, so I'll share this area. Okay, I've shared this area, and then from Inventor, I can just open it up. I can load it up and see the information. Okay, so this is the correct area that I need. So I can load it up in my Inventor. So the data will be exchanged by via cloud. Okay, and then I can add my equipment in. So in this case, I'm adding in my floor, my factory floor. So once I add it in, so I can check the coordination, whether there's any clashes, and so on. Okay, so how to expand beyond constructions? Okay, so when we talk about this particular industries or this particular convergence, right? So as a building product manufacturer, let's say we are building in a modular building or modular design. So we need to think of a way to be more creative, all right? So we can sell our modular building as a package, right? So that others can just view it and maybe change it accordingly via catalogs or configurator. All right. So here is an example from within Inventor. So I'm giving more intelligence to my in this case it's bathroom pot, so I can change accordingly whether I want it to be contemporary, okay, whether I want different types or whether I don't want the bathtub. So in this case it's a room, okay, a modular unit. So I can change the size accordingly just from a dialog box, just a form change. Okay, I want to make it wider. Okay, I want to add panels. Once I click that, it will auto update my 3D models. Okay, so this is very, very beneficial to the salesperson. All right, so once you set it up, your salesperson will be, it will be easier for your salesperson to go and pitch for sales or to pitch or to close deals because they themselves can navigate, can control this. It's very simple, very easy to use. Just that the engineers and designers need to configure all this information, what can be configured, what can be changed, okay, make it into a simple form. So this is available this is the design automation capability that's available within Autodesk Inventor. Okay, so let's say we just changes add panel with, let's say I'm not sure what I want, so I can just change accordingly. Okay, change the door type in this case from one panel to two panel, and then return. So let's say this is what I want. Okay, So I can open the drawing. So once I open the drawings, I can automatically create all the bill of materials or the design details. Okay. And then maybe from here, I can also straight away send it over to or convert it as Revit so-called BIM family. Okay, because it's 3D model, so section view is not a problem. It can be done on the fly. Okay. Then again, digital twin is used to simulate, predict, and informs. Okay. So that we can do all this from plan, design, build, okay, commissioning, handover, space plannings. Okay. So the industry challenge nowadays, the owners are receiving this instead of what they really need is a model, okay, a visualization that can help them to make confirmations, okay, close case, okay. So digital twin maturity starts from virtual twin, connected, predictive, prescriptive, and autonomous. Okay, here is just some explanations or detailed description of what it is. So virtual twin basically like interaction, collaborations. Connected twin I showed earlier is real-time data with IoT sensors. Predictive twin is analytics, okay, to leverage the outcomes and problems for the operations. Okay. Prescriptive twin level 4 is more on machine learning, is more on what if simulation. Let's say you want to know what if this building, what if there's a flash flood on the area? Will the flash flood affect the so-called the ground, the basement parking or somehow? So it can be done. Okay, autonomous twin where everything is run on artificial intelligence. I believe Malaysia nowadays is more up to level 2 towards level 3 maybe. Okay. All right. So let me see if we have a question before I go to the next topic. Okay, so design and make with certainty. So as mentioned earlier, so the future is industrialized. Okay. So productization for building products. So challenges of a building design. So architect want to know their design choices are manufacturable during building design. But current solution cannot provide timely feedback. Okay. So because architect can become very creative and can design a building very special, but can it be produced? Can it be constructed? Can the components be manufactured? So they need collaborations, right? So they need sometimes, if it's very customizable, it probably takes some time to get the feedbacks. Okay. So we can enable design with whenever we plan, we can specify projects, so we can productize the building products. Okay, define products, constraint, and share with partners. So you can do modular design, or you can add all the configuration of what if or what can be configured of your products. This you need to look further of the potential of your products. Okay, select multiple potential suppliers, reduce risk, design with products. Okay, accelerate, complete. All right, let me just go to the next. So under building product, this is where most of us are in, product engineer. Okay, we need to supply to all the people from architect, contractor, fabricator, operator, and owner. And in terms of applications or tools, so building products can be used. So in this case, I'm just mentioning everything that's under Autodesk platform. Inventor, Fusion 360, we use Vault. Okay, and then we go to Revit, AutoCAD, Construction Cloud, Fusion Teams, and so on. Now, to the new things. So Autodesk Informed Design. So we have to design buildings with certainty to deliver faster. Okay. So previously, I've shown how to do customizations. Sorry, design automations. Okay. So we can customize our product family. Okay, and we can, instead of previously, we need to, whenever I send to Revit, I need to, what do you call it? Cut the associativity of the building products. Okay, so previously that's the way we cut Okay, so whenever the design is confirmed, I send the confirmed design to the architect or to the building modelers. But now we can give the same option or the same intelligence, okay, of the configurable content to the Revit users. So you give yourself a more, how to say, differentiate yourself from others. Okay, how to connect the workflow. So delivering a connected workflow, let's say from product engineers. Okay, I bring the products, okay, send to the designers. So building design share, and we build together. Okay, fabrication output and so on comes later. All right. So when you look into products, so we can create parametric model, which is what I'm showing earlier. So we create all that parametric model, we define the BIM content, specify what is the category of the families, okay, alter product rules, all the just now we have width, sizes, panel, okay, all that information we can send over to the Revit users now. So now whenever the architects receive that so-called catalog, they can discover, they can customize themselves, okay, and then they can use whatever they want into their projects, which previously they need to request after every changes. And for production engineer, it's very simple because everything has been confirmed. In the earlier stage, they just open, select product, generate outputs, do their fabrication wonders, and just deliver. Okay, Autodesk Informed Design. So from author and publish. So in this case, it's just on Autodesk Inventor. Okay, I create assembly, I give the product definitions, how we can configure or modify the products. Okay. Okay, so now here is an example. So the same component. So let's say now from this deck, what can I do? So I can control the parameter. So what do I want to control? So I can choose whatever I want to control from that parameter. So let's say I'm creating in the automation. So I can control width, depth. So in this case, you see all this information here. We can change and it will auto update. Okay, now this is done inside Inventor. Right. So this is done inside Inventor because the product is designed and modeled inside Inventor. Whenever there's changes, the drawing, detail drawing also updated. Now, let's say I want to define the BIM content before I share to the architect or to the Revit operator. So what can they do? Or what I need to do? We need to specify where's the insertion point. Okay, what is this thing? What is the connector? What is the type? In this case, the Revit family category is special equipment. So we need to specify what special equipment is that. Do they have Omni class? Any comments you want to add? If not, we just specify the product definitions, give the name, okay, select the assembly, select whatever you want to include. In this case, it's usually the drawings and the parameter we want to give to the architect to control. In this case, we're just giving in width and depth. All right. We can even add rules to it. All right. So this rule is like you're giving in logic to the product. So let's say depth minimum is 1,000, depth maximum is 5,000. Okay, and then let's say, let me pause over here. Okay. Now what is showing over here is on the top, depth, minimum depth is 1,000. Maximum depth is 5,000. Okay, depth increment, I mean, we can add the sizes like every 100. So let's say minimum is 1,000. I can add 1,100, 1,200. So that's the increment. Okay, and then the next rule is on the width. So minimum width it will be 1,000. We cannot go lower. Maximum width is 5,000. Okay, and then we're adding in more logic rules. Okay, so this is like just giving in conditions. Like example over here. Okay, depth of the value must be more than the width value. Okay, so depth value equals to width value. So if depth value is more, so let's say I adding in my depth, right? I give my depth size is more than the width size. So what is the rules. Okay, so if I do this, okay, it's automatically, the rules will run automatically by making the depth and the width the same value. Okay, and then you can see the last line there, you have green color box, right? Depth cannot exceed width. So this is the so-called, it's like the error message that will pop up. So now, let me just update. So let me purposely change the depth to 3,500 and I will get a warning. Depth cannot exceed the width. So this is like a simple programming without having to have the programming experience or programming knowledge. It's very visual. It's very easy to visualize and to create. Okay, this is like what's the automated rule we can do. So let's say every time we do this, create a PDF. What else we want to do? Maybe create a step files, create SAT files. Okay, and then publish. So let's say what I want to publish it. So I can save it to, this is my centralized locations. Okay, it's on the cloud. So this is where we do the projects together. So now the next, after I publish, so those with Revit can also access it. Okay, because the product has been defined. So now the Revit user can just grab it and use. Okay, discover the product, customize the change the site accordingly, insert to their building. Okay, so now if they are discovering the product, so let's say so in here, so I want to add the products. Okay, the one that I just sent over just now, okay, is the balcony. Okay, so this is the modular design. Okay, so I mean I add it, I put it on top of that building. Okay, so that's one. So and then maybe I want to add another one. This is, remember, this is all created from within Inventor and share on the cloud. Okay, and then from I just now want to add my balcony. So customize the size. This is, you see, you remember that we only giving options to them, only able to control depth and width. Okay. So let's say we adjust, change the size accordingly. So the Revit owner or the architect do not need to worry about the fabrication details. All that has been done with the building product manufacturer. So in this case, it's me. Okay. So when I insert it into building, and we can see how it looks like in place, whether we need to make some changes of positioning or size. In this case, we need to change the size a little bit, make it wider, change the width a little bit. Okay, and then it's just update. So just remember that these components, or these building components in this case, is shared on the cloud. You don't need to like download anything. You don't have to use thumb drive to share. It's all on the cloud. Okay, so once all that is done, so we can preview it. So this is also one of the viewer, also online. Okay, if all looks good, then we can see all the properties that we shared, that I shared earlier, is available there. All right, so that's on the architect. So if we look into the production engineer, so that's very simple. They just use whatever that has been confirmed. Okay. Let's say that project, they just go to that project. If that has been confirmed, they just open the confirmed versions, the confirmed model, and work on the confirmed measurements. Okay, let's say balcony. So they can just download the reports. Okay, generate outputs. So they are having in the drawings. So let's say they just download the drawings, and then they can start to fabricate. Okay. So we have now the outputs, so the fabrication output. So we have all the documents ready. So now all the Excel, okay, of what part is needed to be purchased, what part needed to be manufactured is all already available, and it's on the cloud. Okay, so this is where the fabricator only open the confirm model and confirm drawings. All right, so that is design and make with certainty, or Autodesk Inform Design. Okay, if you have questions or you want to learn more, you can let us know.